You're listening to the SPE Podcast. I'm Paige McCown, and we're talking about the SPE International Drillbotics competition with
Fred Florence
and Enrique Losoya.
Welcome, everyone. Thank you for joining us today. I want to welcome my guest today, Fred Florence. Fred is president of his own consulting company, Rig Operations, and he's a founding member of the SPE Drilling System Automation Technical Section. And Enrique Losoya, who is a doctoral student in petroleum engineering at Texas A&amp University and led a team of students to first place in the 2017 SPE DSATS Drillbotics competition. So welcome, Fred and Enrique. Thank you for joining me.
Thank you for the invitation.
Thank you for your time.
Great. So as I said, we're going to discuss drilling automation and the SPE International Drillbotics competition. But before we dive into the competition, I wanted to talk a little bit about drilling automation. Fred, you're a founding member of the DSATs and have been in the industry for more than 45 years. So can you talk a little bit about why drilling automation is so important and maybe how it's changed the discipline?
A number of us were involved in working with the control systems on a bunch of drilling rigs as things were changing, mostly about 20 years ago. And we built supervisory control systems that allowed the driller to sit in a chair and control multiple machines, in some cases simultaneously. And we realized that this form of mechanization could be used in a form of automation. So the drilling machines were robots, but what we wanted to do was make the robot smarter to help the driller do his job better. And in some ways, it was to avoid problems. I think the biggest issue was how can we avoid making mistakes that are costly or dangerous? And how can we improve the efficiency in some fashion? So that's where it started. Several people got together at a technical conference and decided to form a group that became the technical section, Drilling Systems Automation. And that was really formed so that we could facilitate the introduction of automation so that we could communicate to people who were not familiar with it what it could do and what values it could bring to the industry. And it was slow to grow, but there's over 1,000 members there today. And there's other technical sections that are using some of that automation for data and modeling for everything from managed pressure drilling to automated directional drilling. And I think these changes are more important today because of the reduction in the price of oil. There's a huge drive today to be more efficient. There's any cost margins are really cut very, very narrowly now because of the low price. And so anything that the industry can do to avoid costly mistakes is really important. And I think it's probably more so now than it was when we started.
Yeah, you're right. Especially in today's environment, it's very important. So hopefully the work that you've been doing over the years will help us get through, what we've got ahead of us in the industry. So that's great. So let's talk about the competition. What is Drillbotics, and how does that competition work? How was it developed?
In short, Drillbotics is a competition for college students to design and build an automated drilling rig. It's on a laboratory scale, about 5 or 6 feet tall, 7 feet tall. And the idea was for them to understand what automation is and the problems of getting there. It started, of course, with DSATs, and later at a forum in Paris. I was talking with somebody who had a miniature rig in Austria, Gerhard Tannhauser at the Montan University in Leoben, built a mini rig to teach his students about drilling. And when I saw that, I said, what if we made a competition? And walked around the room, a lot of people said it's a good idea. So we came up with really strange name called the International Student Competition. And then John McPherson said, Fred, go find a better name. So I went to Google and I started Google potential names. I came up with something called Drillbotics. And I walked around my office and said to everybody, what is Drillbotics? They said, I don't know. And I said, well, what do you think it means? Well, drilling with a robot or robotic drilling or something like that. So I went out and trademarked the name, and that's how we got it.
Yeah, that's great. You definitely need a more diverse name or a more specific name than international competition.
Well, our main purpose was to get students that were newly minted, coming right out of the university, that then became drilling engineers, where they were not afraid of drilling automation. A lot of old folks didn't understand it. They're scared of computerized technology in the industry, which is difficult at the field level. And at the time that we started, we didn't have the technical knowledge and types of hardware available that we have today. So it's a lot easier to do, still difficult, but a lot easier to do and safer to do than it was originally. And if we can get students to understand and not be afraid of it, then they're probably going to be willing to deploy it. And then the second half of that was we want them to do research and come up with things that we can't come up with. So we try to challenge them not just to build a machine, but to learn from it. And we actually score the winning team on how much they learn, not on what they do. It's not how fast you drill. It's not where you drill. It's what did you come up with? It's novel. It really shows that you've learned something that the other people haven't seen.
Right. And it's kind of passing the torch to the next generation to kind of, like you said, take the automation and come up with something different and not be afraid to push it forward.
Absolutely. And these are really smart young men and women from all over the world. They come from every country imaginable. The university might be in Oklahoma, but they have people from 4 different teams, 4 different countries that are on that team. And so the other thing that they had to come up with was an interdisciplinary team. So what we saw before was we have all these silos in the industry. We have electrical people that don't know anything about drilling. We have drilling people that don't know anything about control systems. We have people that know controls and drilling, but they might not understand how to do it in real time. And real time may be in the sub-second type of range. And so there's a lot of things that have to happen in our industry that are interdisciplinary. So we thought, let's go brainwash these guys right now so that when they come out of school, they'll fit right in and actually become leaders.
Yeah, they learn to work on a team together. So Enrique, that was kind of one of the things that drew you to this competition was the interdisciplinary part of it because you were passionate about that. Is that one of the things that got you involved?
Oh, that's correct. That's absolutely correct. Yes. So honestly, 3 years ago, I was starting my master's degree, and I was struggling to find a project where I could bring my bachelor's experience because I had a bachelor's in mechatronics engineering. It's kind of robotics and automation, and those knowledge, and then apply that knowledge to these newly learned knowledge during the master's degree, right? And that's where I found out about robotics, and I was instantly drawn into this project because it was the perfect fit. It was a blessing to me. Well, back then, I was like, here I could have my passions, my skills, and then bring this real live automation challenge and drilling engineering into a fun, fastly paced, and collaborative competition. So it was really, 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 really nice to have found this competition.
So, like we said, you were on the winning team from 2017. Can you tell us about your project and the challenge that you had to solve?
Yes. So the competition is, as Fred mentioned before, is basically come up with an completely autonomous and automated lab scale rig, and it only has to have 2 kind of just the start and stop, and honestly, just the emergency start and stop. Everything else has to be automated from start to end of the drilling process. And not only that, but you also need to optimize drilling. And okay, yes, optimizing ROP is one point, but you also need to worry about not breaking the drill string or the drill pipe that you have in there. And then you also need to worry about how can you couple, instrumentation, real-time control systems, downhole sensors, wireless transmission systems, and a little bit of machine learning and dysfunction identification in real time. So that was quite a challenge, and we had to basically engineer and direct all the design on the electrical system, on the control systems, on the algorithms, and on the machine learning identification as well, and then bring them all together into, well, just basically for the judgment day, right now at the end of the competition.
Well, I'm sure it was stiff competition too, because there's a lot of schools involved. And I mean, do you know, Fred, do you remember how many teams you would have in, maybe one year or maybe the last year, how many teams?
Well, we started with 4, and
Yeah.
last year there were 16.
Oh, there you go. Yeah. So Enrique, back to your story. So what did you learn from this competition, and how do you think it has prepared you to enter the industry?
Back then, I was still very inexperienced and very afraid to go into the industry. Don't get me wrong, I'm still very inexperienced, to be honest. But it really provided me a massive window into other disciplines within the petroleum engineering, as Fred was talking about, these silos, right? And on petroleum engineering, we are not usually taught carefully in the curriculum, like real-time drilling optimization, control theory, machine learning before it was thrown out everywhere, and programming skills. So I had to improve my prior knowledge and learn new stuff, but at a deeper level, to fix the issues that we were facing. Then I'm pretty sure those skills will be they prepare me for more challenging technical engineering projects down the road. Now, having said that, I feel like the most important skills acquired through Drillbotics for both my career-wise and personal growth were collaboration and team management. Without either of them, honestly, our team wouldn't have succeeded in much less won that year.
Yeah.
It really taught me to be much more collaborative. As a grad student, we are just focused on our project, and it's a very individual kind of task. Focus on your research, get the papers out, write the thesis, and everything is individualized. So your success depends on you and you only. Kind of, not all the time, of course, but most of your success, though. But then you go into real life and you realize you need a team. You need a team to be successful, and the amount of stuff that you will be able to achieve individually are nothing compared to what you'll be able to achieve with a good team. So I believe that identifying those passions and skill sets linked to different types of personalities, and in such a multidisciplinary team, because we had an electrical engineering team, we had a mechanical engineering team, we had drill engineer, production, etc. All students from different departments, and then we were learning from each other, right? The electrical engineer was teaching us how the circuit worked, and we were teaching the electrical engineer what drilling was, and etc. So that realization that keeping the team focused on the essential details of the project while respecting and encouraging their self-discipline and work boundaries led to huge strides on everyone's progress. And to me, that was and still is the best lesson Drillbotics teaches students and future professionals.
Yeah, that's great. I mean, hands-on learning, especially too. I'm a big proponent of that, and I think it really helps students move into the industry, no matter what industry it is, with some practical application. Well, let me ask you this. You said you were afraid to go into the industry. What's behind that? Because that's a concern actually that a lot of students have right now because of the cyclical nature of the industry. But what was your hesitation in the beginning?
Since I didn't have a bachelor's, or I didn't have any prior knowledge in petroleum engineering per se, everything was new to me, and I was completely unprepared for what was out there. And not only that, but I went straight out from my bachelor's into a graduate degree. So I didn't feel ready to be faced with real life challenges, or to be competing at this level, and to be adding value to the petroleum engineering realm.
But this definitely helped prepare you.
Absolutely, yes, it did. It was a blessing.
Are you considering becoming an SPE member? When you join SPE, you join a society of dedicated professionals just like you, working to address the technical challenges of the global oil and gas industry. SPE membership gives you the opportunity to make local and global connections and build a network of influential technical leaders from every discipline. Learn more at spe.org/join.
So Fred, tell us a little bit about how the competition has evolved over the years.
We started off with a competition that was very limited. We had a single block of sandstone cut in half with a sliver of marble stuck in the middle. And we told people, go build the rig, sit it on top of this thing, and dig a hole through it. Oh yeah, and we gave them a piece of spaghetti pipe. So if they tried to muscle their way through it, the pipe would break. We provided the bit for them to use. And they all came up with different concepts of how to do it, and all of them failed. Everyone had the pipe vibrate into or buckle or some other type of failure. Everyone failed. And that was great because you learn from failure. And the next year, only one team failed. And so we changed the pipe a little bit to give them a fighting chance, but we still knew that they would have to understand the physics of what they were doing. And we wouldn't tell them. We'd give them a couple of references, but they had to figure most of it out on their own. I might back up a little bit and say the way that the competition is structured is in the fall term, the teams produce a design report. There is no physical rig, it's just a design. And they have to send that by New Year's Eve. And in January, the judging committee reviews those and selects finalists. And finalists then build the rig in the spring. And then at the end of the spring term in May or June, judges would go to the schools and witness them drill. And then the judges would get together afterwards and pick the winning teams. And the prize was always a chance to get a paper published at an SPE conference. It evolved into the program committee of the SPE IADC drilling conference, giving us a permanent slot for a paper. And then we also flew the team and their supervisor to the conference, wherever that was, and paid their way there. So they come out of school with a publication on their resume and a lot of experience. So that was the prize. Well, anyway, we kept making it harder and harder. Of course, they all figured out what to do, so we had to make it harder. So I started making the rock in my garage, and I used different types of materials at various angles. In the drilling world, we call it formation dip, and we had huge formation dip of 45 degrees or more. And they had to be able to drill through this hands-free, and they had to recognize you're going from hard to soft or soft to something else. And what should be the optimal drilling parameter as you go through this new rock? Well, they had to find out ways to do that autonomously. And so one of the things that the team from A&M did is they looked at vibration signatures as they were drilling different types of rock, and they decided, based on what we see, based on what we can measure, we believe we're in one type of formation. And when they saw different vibrations, they said, all right, we're now in a different formation. And so what they were able to do was to change the parameters quickly during the transition, when half of the bit is on one type of rock and the other side of the bit's on a different strength of rock. And they were able to do that in real time. And it was really amazing. And that's the kind of things that in the industry, when we are drilling with an auto driller, it may take too long for the auto driller to recognize we're in a different formation. And so some of the things that they came up with, in my opinion, are patentable. So it's a research project. It's not a science project. So we kept giving them harder formations. I guess the hardest was the time that I put the piece of rubber mat in the bottom of it. And when they drilled into the rubber, it just kind of got everything to stick like drilling tar in the Gulf of Mexico. Most of the folks were pretty surprised and almost upset with me, but they also were able to drill it. So that was good. And then we started into a harder challenge, and that was hands-free directional drilling. So the first year was go down a certain depth, kick off and see how much angle you can build in this direction. and they didn't have a specific target. It was just build as fast as you can. And then eventually, of course, we gave them a target. And then last year we had it all set up to have 2 targets. So they had to drill down through a point. They had to drill down, make a turn, go through a point, make turns to go through a different point. So true directional drilling. And all of this with a 6-foot tall drilling rig. Oh, meanwhile, you've got to make sure that you don't burn the bit. You've got to have the right kind of lubrication. You got to make sure you don't damage the pipe. Oh, the electronics. By the way, the electronics are getting cooled by water. Electronics don't like water, so they had to learn how to make and seal downhole sensors and things like that. Again, it's a research project, not a science project.
Yeah.
So, I mean, it's tremendous what they have accomplished. They are young men and women, but because I'm an old guy, sometimes I refer to them as the kids. And when I hear people my age in the industry tell me what we can't do, I say, don't worry, we'll give it to the kids and they'll show you how.
Yep. Absolutely. So you mentioned patents. Have there been any patents that have come out of any of these projects that you know of?
Enrique, what's an update from A&amp?
Oh, yes, actually. We submitted a patent application in 2019, last year, and it's still pending. But hopefully we'll get it granted. Yeah.
That's
It's
awesome.
related to this formation identification process that we came
That's
up with.
amazing. That's amazing. I mean, yeah, that is a big prize, right? Coming out of school with papers and patents, and that really puts you ahead of the competition out there.
There's a team from Germany, University of Clausthal. They are in an area where there's a lot of geothermal drilling, a lot of hard rock. And they came up with a different type of bit. It's a percussion type bit, a hammer drill, if you will. And they are been working with the company now. I don't know if it'll be their patent, but I think that company may actually build their design. There's a team from Norway that came up with a bit that it looks like there's a Norwegian company that is going to manufacture the bit according to their design. So it's you got electrical and mechanical engineers designing bits. I mean, there's all kind of crazy things that happen on these teams.
Yeah, no, but it's good though, because that's what you have to do when you get out in the real world, right? Work with
Exactly.
teams. And we talk a lot about I work with the energy education program at SPE, and I get a lot of questions about what is the industry looking for in a student or in a graduate. And everybody that I've talked to or anybody that I've interviewed said you've got to solve problems.
Yeah.
You've got to be able to take the information and come up with an answer to it. So this is a great learning experience, I think.
Well, I remember in one of the first years when in the middle of the competition, we changed the size of something and they all complained. And I said, well, we build iron roughnecks and pipe handlers for a certain size drill pipe. And then all of a sudden, the people that manufacture drill pipe come up with one that's a different size. We have to deal with it.
Yeah.
So here's their instructions, deal with it. And they
Yeah.
did, and they did.
No, this is great. I love it.
Much of the work of the Society of Petroleum Engineers is accomplished by members. Become a volunteer and use your knowledge and experience to influence SPE programs and activities. As a volunteer, you can enhance your leadership skills while meeting and working with other SPE members from across the globe. There are many opportunities to get involved, regardless of your experience, location, or experience level. To learn more about the League of Volunteers, visit spe.org/volunteer.
So, with what's happened over the past, oh my gosh, it's only been like 5 months. Fred, what is the impact of COVID-19 on the competition?
Well, it was devastating for us in 2020. So the 2019-2020 season was devastating because the students were not allowed to meet. They couldn't meet in person in school. They couldn't go into a lab because of the need for social distancing. And so it was just impossible for them to do that. In addition, most of their classes were canceled and they began to use remote school of some remote classes of some form. And so that was traumatic for them, just that one change. we looked at how we might be able to do the test remotely, but we recognized how much pressure we were putting on the students over and above what they already had. And so we decided to pull the plug. So we did cancel the 2020 competition.
Oh, that's too bad. So what's the plan for moving forward?
As we go forward, we've had some preliminary meetings to write the guidelines for the 2020-2021 competition. We initially assumed that none of the schools could meet, and so we talked about having a virtual competition only. But we've had some schools from predominantly from Europe and one from the United States that says they can meet, and they would like to have a fiscal rig competition as well. For the 2019-2020 competition, we recognized that some schools could not afford the $10,000 charge that it often took to build one of these miniature rigs. And so we decided, give them a chance. Let's let them build a virtual rig. And so people did the research, had to understand how these different drilling machines worked, and had to model each of those machines, and then model a control system to control them, to model some kind of downhole formation, and where the bottom hole assembly could react to that formation. And then they had to be able to drill a directional well, but it's all done virtually. And unfortunately, we had to pull the plug on the 2020 competition because of the virus. And so we didn't see the end results, but some of them had made some really good progress. As we move to 2020-2021 competition, I'm just going to call it the 2021 competition, we'll probably go with a virtual design. It may be identical, a couple of fine-tuned points on the guidelines from last year. So it may be that they do the exact same thing and build a virtual rig. And we'll meet, and the committee will meet in the next 2 to 3 weeks to try to determine what that will be. We do have some schools from Europe, one from the United States, that can meet in person at the lab, and they would like to continue with the mechanical rig, and we'll see if we can accommodate that, how they can have that done where the testing is done either remotely or virtually or something that could be done next spring. So there's a couple of things for us to work out.
So can teams still sign up for it, or has the deadline passed for signing up for the 2021 competition?
No, and we haven't even put the registration on the website yet. Our goal each year is generally to have the guidelines finished in July to August, where they can have the guidelines the first week of September, when most of them return to school. And we give them a couple of months to register.
Oh, that's good. And so people who are interested can go to drillbotics.com to see that information and sign up if they want to, if they haven't already.
Right. There's not a form to sign for this year's competition. There will be shortly. The blog that's there will tell you the latest news.
Well, this is so exciting. I love, like I said, I love the hands-on learning and the practical experience. Enrique, is there anything you can give any kind of advice for teams that are signing up for the competition coming up or that are interested in it?
If they decided to sign up, they should start getting their team members now and just go on the website and sign up for it. They're not going to regret it.
That's great. Well, Enrique, Fred, I really appreciate you being with us today and telling us about this competition. I think it's very timely, and it will help a lot of students out there who are looking for something to get some hands-on experience.
I'd like to say one thing is a lot of people have heard of the program and they look at our committee and what we might be doing. But what I really want to do is recognize the large number of people who've made this happen. It's not just 4 or 5 people on a program committee. It's really dozens and dozens of people along the way. It's people who have given their time to be on one of the design committees of the program, writing the guidelines. Others who were judges that have flown around the world to judge the competition. Some of the people who have recruited new schools And just because they thought the program was nice and their alums that said, I believe my school has a good competition, they got a chance to compete here. We want to give them a chance. And they've recruited some really good teams. People who have worked within DSATs to keep the program funded. Now SPE is funding the program to a large extent. And then the number of people and the number of hours that go on in the background to make all these things that seem invisible to everyone else. It is a tremendous effort by SPE and DSATs and other technical sections, DUPTS and Wellbore, certainly. Without all these individuals, this program wouldn't be what it is. And I really want to thank everyone.
Yeah, that's a good point. Thank you, Fred. I appreciate it. So again, thank you, Fred, Enrique, for being with us today. And we hope to spread the good news about drillbotics and how it can help drilling students.
Thank you, Paige.
Absolutely. Thank you for inviting us. Thank you.
Let's keep the conversation going. Use the hashtag SPE Podcast on all your social media to reach out and leave comments and reviews. We'd love hearing from you. You can find SPE Podcasts wherever you get your podcasts. Search SPE Podcast on iTunes, Spotify, and TuneIn. We're also online at spe.org/podcasts. I'm Paige McCown. Thank you for listening.